Howdy folks, welcome back for the next video in this series. So we are looking at page 4 now for our exam 1 review for Math 120. And so we are looking at some rational and irrational questions here. They just wanted you to categorize it correctly. So we have our square root of 10. So the biggest thing is, can this be written as a terminating decimal or a repeating decimal? And if you put that into your calculator, you can see pretty quickly that it's not a nice number. So, I mean, it looks like there might be a little bit of a repeating going on at the end, but if you were to keep going, if you had a larger calculator, you'd see that it doesn't come out to be a nice answer. So in this case, it would be irrational. Square root of 16, on the other hand, is nice. It's a perfect square. So in this case, because it's terminating, it would be rational. 0.01, again, there's no other decimal places. It's finite, so it stops. In this case, so it must be rational. 0.01 with a bar over it, with an over bar. Well, again, that means repeating. So by definition, that is rational. E, okay, this one's a little more interesting. So we got 0.01, 011, 0111, 0, and now the assumption is that the pattern continues. So we had 1 1 here, 2 1s, 3 1s, and then there'd be 4 1s and so on. So we know what the pattern is, but is it a consistent repeating pattern? The answer is no. So even though the 3 dots tell you it goes on forever, there's not a repeating pattern to it. So in this case, it is irrational. And then pi is one of our key examples for irrational numbers. Never ends and never has a repeating pattern. So that's irrational. All right, so moving on up the page, or down the page, depending on how you look at it, right in simplified radical form. So we have the square root of 150. So remember, this is all based off of your knowledge of perfect squares. So remember, you're trying to find a perfect square that divides evenly into that number. So go down the list. So 4 is the first perfect square. Does 4 go into 150 evenly? No good. So then we keep going. So 9 would be the next one. No. 16 would be the next one. No. 25 would be the next one. 5 times 5 is 25. That is a winner. That goes in to our 150. So the next step is to separate it. Put that perfect square first. And then what the rest of it is, well, how many times does 25 go into 150? And it goes in 6 times. So that's always the layout for the next step, is that you have your perfect square piece first and your not perfect square piece second. And so now we can replace this whole thing. This whole square root of 25 can disappear because we know that's equal to 5. And so that just becomes 5 square root of 6. And you're done. We can't reduce this square root of 6 anymore to make it more smaller or anything like that, so we're done. Now, when we have a square root in the bottom, remember, we don't like those, so we have to get rid of those. And the trick is to multiply this whole fraction times 1. But it all matters in how we write that 1. So if we write that 1 using that square root of 7 as square root of 7 over the square root of 7, this whole fraction is equal to 1. So we're not changing the original fraction. That's the key. You can't just multiply the top by something and not the bottom. It's got to be the same thing on the top and the bottom. Now, this is a multiplication problem, so you might be saying, well, wait a minute, what about cross-canceling and something like that? And the answer is you don't want to do that, because then it puts you back to where you started. So you want to do something with it as is. Now, normally, when you're multiplying fractions, what do? You multiply the tops and the bottoms, and that's what we want to do here. So the tops, we can't really combine them other than just squishing them together. But on the bottom, remember, if you have two square roots that are multiplied together, you can smush them into a single square root. But the trick is that you got to multiply those numbers together. So in this case, we end up with the square root of 49. But 49 is a perfect square. So we can now replace that whole square root on the bottom with 7. 7 times 7 is 49. So the square root of 49 goes back to 7. And that would be your answer. All right, so let's keep moving down the page. Now this next one, I want you to try to combine a couple of square roots by adding or subtracting, in this case subtraction. Problem is, those square roots are not the same. We can't combine them unless they're the same. So we have to do some breaking down. Now, 32 has a perfect square factor of 4. 4 goes into 32 evenly, but there's a bigger one, and that bigger one is going to be 16. And then 16 times 2 is 32. So remember, these two always should multiply back together to get what you started with. So that's the key. Now, what's nice about being able to break this one down easily is that you can cheat a little bit. I shouldn't say that, but you can kind of use this to your advantage. So in this case, because 2 is as small as this square root's going to get, we hope that there's a square root of 2 over in here. And if we divide 2 into 128, the result is 64, which just so happens to be a perfect square. So now you've got your perfect square, non-perfect square set up for each of these. Now let's simplify those down a little bit more. So the square root of 8 we can replace, square root of 16 we can replace with a 4. 4 times 4 is 16. 64, square root of that is going to be 8. And now we can go one more step and do those multiplications. So 2 times 4 is 8. 8 and 5 multiply to 40. And so now we have the same square root. So now we can combine those together. And all we care about is looking at those numbers in front. So 8 minus 40 is going to be a negative 32. And then we still need that square root of 2. Think of that square root of 2 as like a fruit. If you have 8 apples, take away 40 apples of the same type, you end up with a negative 32 apples. So, all right. Now, the last one down here, we want to round. So again, place values, place values, place values. You have to know those place values. So in this case, if we're rounding this to the nearest 10, so 10 is on the left side of the decimal point, so we're looking at the 4. The number to the right of the 4 is a 6, so that tells us we need to round this 4 up. So we're going to get a 3, a 5, and then remember the rule is to just replace everything with zeros after that. Now we don't need to put all those zeros on the left side, or excuse me, on the right side of the decimal point, so we can just leave it off. So 350. Now if we want the hundredths spot, hundredths is on the right side of the decimal point, and it's not the first, but it's the second decimal point. So this 4 is our rounding digit. The number to the right is a 4, which tells us to leave that 4 alone. And everything after that 4 is next. So we got a 3, a 4, a 6.04. Thousandths. Thousand spot is the next one over. So the second 4. But now the 9 tells us we do want to round this 4 up. So that's going to have to change to a 5. So all the other digits come down. And so we end up with that as our rounded answer. And that wraps up page 4. So stay tuned for the last page. See you soon.